Hey guys, in this video I'm going to review intermediate value theorem. This is something that's probably going to be on the free response part of the AP test. It's probably also going to be on the multiple choice part. So it's a good thing to know. So I just have kind of a few quick examples to help us with this. This first one says the velocity of a car is graphed below on 0 to 2 hours. So here we have 0 to 2 hours. Time is in hours. Over here we have velocity. This should say miles per hour over here. And it looks like we have 2 points right here, and there's just a graph connecting them. So it says, does the car have a velocity of 4 miles per hour somewhere on this interval 0 to 2 hours? And explain. Well, if you think about it, velocities are listed over here. You know, if that's 20 up there, maybe this is 10, maybe this is 5. 4 might be right below it. Yeah. It probably does have a velocity of 4 miles per hour. But the reason is the intermediate value theorem. Intermediate value theorem says as long as your function is continuous, if you're given 2 endpoints and your value 4 is in between those, our 2 endpoints had y values of negative 10 and 20. And since 4 is in between those, it has to hit that. Basically, the intermediate value theorem says that if you have a continuous graph, you could draw it without picking up your pencil, it's going to hit every single x value and every single y value as you go from one point to the other. So since 4 is in between negative 10 and 20, we can definitely say yes, the car has a velocity of 4 miles per hour. Like everything on the AP test, the wording is really important. So I would say yes. And there's 3 important things you should mention. You should mention these 2 points, and you should also mention that your graph is continuous. And for the 2 points, I might use function notation. Our function's called v. I'm going to call this v of 0 equals negative 10. All right, so I'm going to say yes, since v of 0 equals negative 10, v of 2 equals 20, and our graph v of t is continuous. And I'm going to say on the interval 0 to 2 hours to be very specific. That's basically the beginning. 3 important components to that. You have to mention your 2 points, and you have to mention your graph is continuous. You could say yes, because all of those things, and then you could really just state what the problem is asking, and then at the end say by the intermediate value theorem. So yes, since v of 0 equals negative 10, v of 2 equals 20, and v of t is continuous on 0 to 2, we know the car has a velocity of 4 miles per hour on the interval 0 to 2 hours. Literally all I did there was copy the problem exactly, just to make sure you're very thorough. And then at the end you should say, by the intermediate value theorem. And you're allowed to abbreviate IVT. Even on the AP test, they will know what you're talking about. So again, really just state those 3 components, the 2 points, and make sure you mention the graph is continuous, and then really state the problem, and state why we know by the intermediate value theorem. All there is to it. All right, remember the graph must be continuous. So if you go to my next example, this graph right here is not continuous. All right, it's a similar situation. They say the velocity of the car is graphed below on 0 to 5 hours. So this is 0, and it says does the car have a velocity of 6 miles per hour for some time on 0 to 5? Well, I only gave you these 2 points, 2 and 10. 6 is probably somewhere in the middle. It might fall where that discontinuity is. You know, I don't exactly know. It might hit 6, it might not. I'm not sure about that. But you really just can't make a conclusion here. We cannot say that we know the car has a velocity of 6 because the graph isn't continuous. You know, there's a discontinuity here, and it's right around where 6 would be. So we have to say that we can't make a conclusion because the intermediate value theorem does not apply. because this graph is not continuous, it's not going to hit every x value or every y value in between your endpoints. So let's just say we cannot make a conclusion since v of t is not continuous on 0 to 5, and therefore the intermediate value theorem does not apply. All right. Just doesn't work in this case. All right. Last one more example, kind of a similar situation here, but I just gave you a table. All right. This says v of t is a continuous function that models the velocity of a car on 0 to 12 hours. So notice, even though I didn't give you a picture, I'm telling you it's a continuous function. If you saw, a graph of this, it would be continuous. You could draw it without picking up your pencil. It says on 0 to 12 hours. That's exactly what our table is for. We have some velocities listed here. So over here I have some questions. Does the car have a velocity of 15 miles per hour on 4 to 6? Explain. So be really careful about that. 4 to 6, that's right here. We want to know a velocity of 15 miles per hour. Well, at 4, it's going 10 miles per hour. At 6, it's going 22. Does it have to hit 15? Yes. Because 15 is somewhere in between 10 and 22, it will definitely hit 15 miles per hour since it's a continuous function. We know it has to hit all the values from 10 to 22. So we can say yes by the intermediate value theorem, and we should mention both points, and we should also mention that v of t is a continuous function, so we're very thorough here. So I'm going to try to write small. I try to zoom in on this so you can see, but I'm going to say yes, since, I'm going to mention my 2 points, since v of 4 equals 10 and v of 6 equals 22, and v of t is continuous, we can say by the intermediate value theorem, the car will have a velocity of 15 miles per hour on 4 to 6. I'm kind of running out of room. A velocity of 15 miles per hour. Sorry about that. All right, remember the key components here. I kind of ran out of room there. Definitely, you need those points. You got to mention both points. You got to mention the function is continuous, and you should mention intermediate value theorem. They want to know what you're talking about. And other than that, just to make it a complete thought or a complete statement, you should kind of mention exactly what the problem is saying. If you just say yes because my 2 points and the graph is continuous by intermediate value theorem, it's not really a complete thought. You should finish it by copying the rest of the problem. The car will have a velocity of 15 miles per hour on 4 to 6. All right, the last one. Does the car have a velocity of 15 miles per hour on 10 to 12? So let's look at our interval 10 to 12. That's right here. If you look at 10, it has a velocity of 50. At 12, it has a velocity of 70. It's going to hit every velocity from 50 to 70 since it's a continuous function. It could possibly hit other velocities, but we don't know for sure. It's only going to hit everything between 50 to 70, and 15 miles per hour is not on that interval. So I would just say we cannot make a conclusion here because 15 is not on the interval 50 to 70. So I would say we cannot make a conclusion. So that's just a little bit about intermediate value theorem. That might help you when you're completing some of these AP problems, and also it might help you on the multiple choice as well.